Ahoy mateys! Welcome to our MEGN 301 video presentation. We are the Plastic Pirates and today we'll be showing you our injection molder. Our team from left to right is Jared, Gabe, Ryan, Katya, Nicole, and Cammie.
The goal of this project was to create an injection molder that melts recycled plastic and can form it into a desired mold. The inspiration for this project is the world plastic crisis. Single-use plastic pollutes our waters and endangers animals and our own health, and plastic does not degrade quickly in the environment. The company Precious Plastics was also a big inspiration for us, as they are creating devices like ours to help with this issue on a larger scale.
The objectives for our project were determined from our preliminary research and ideas and were what we set out to accomplish from the beginning of the project. Our objectives included setting a mold within 1 minute of our volume of plastic melting, having a set volume of plastic worth 6 iPhone cases, and being compatible with PET, ABS, HDPE, PP, and PVC plastics. The constraints of the project were both set by the class and by our team.
The PID controller shown is mounted on the side of the aluminum frame and is connected to the heating tape and allows us to set the appropriate melting temperature of the plastic. On top, you can see how the 2-ton scissor jack is mounted to the frame using 2 angle brackets. The plate that the jack is attached to is able to slide along those angle brackets to allow for easy access to the injection tube. Looking into the overall frame, you can see how the plunger is screwed onto a bolt connected to the scissor jack, and the plunger head is JB welded to the plunger rod. Below that, you can see the injection tube with the heating tape and insulation wrapped around it. This is where the plastic pellets are poured into to be melted. The injection tube is welded to an angle bracket that is mounted to the frame. The angle bracket has an injection hole in the bottom of it where the plastic is pushed through into the mold. Right under the angle bracket is where the aluminum mold that was CNC'd is slid into place. For the second video, you can see the injection molder in operation. At this time in the video, the plastic has already been melted and the jack is being hand cranked to press the plastic into the mold. As you can see from the video, there is not a good enough seal between our plunger and injection tube, so as the plunger is jacked downwards, plastic starts to come back up the injection tube around the plunger. Ideally, once the plastic has been injected into the mold and has solidified and cooled, the plunger can be easily slid out of the way and the mold can be slid out from under the angle bracket to retrieve your newly made part.
The successes and shortfalls listed on the slide are what we are able to accomplish and what we came up short on based on the objectives and constraints talked about earlier. The main successes that we had were the desktop size of our prototype, that the PID allows control of temperature ranges from -50 to 1300 C. It was compatible with various plastic types as we used both ABS and polypropylene. The production speed was less than 1 minute and we came in at right under the budget. However, we had some shortfalls of an inadequate plunger fit and seal, which was manifested by the fact that plastic would come out of the reservoir as we tried to put the plunger in. The injection hole diameter was too small and we hit an ambitious volume amount.
Some improvements we would like to make to our prototype would be to create a better seal between the plunger head and the heat tube so that we don't have backflow issues. To do this, we could use 2 washers with a heat-resistant Teflon washer sandwiched in between them. Another change would be to reduce the distance that the molten plastic needs to flow in order to reach the mold, which is done by making the mold thinner in the Z direction. To better meet our metric goals in another iteration of this prototype, we would like to make the chassis lighter weight and try to reduce the amount of time spent machining the chassis. To do this, we could use something such as square steel tubing welded together that is both strong so that less material needs to be used to withstand the forces the chassis will experience, and is also low cost. The second metric goal that this would help achieve is an easier removal and placement of the mold because the chassis will have less material to work around.
Thank you so much for watching this video. We are excited to see what our project can do in the future.